Okay, what we're going to be usually caring about moving forward is what do these sequences look like as n approaches infinity? What's the end behavior? And for both of these examples, the list of numbers is going to end up going off to infinity. As n approaches infinity, so will the SNs, and they both or one of them gets exponentially bigger, the other one constantly bigger. I want to do one more example. So we're going to call this example 4. And we're going to say that our sequence is defined to be -1 to the n over n. Okay, so just real quickly, this sequence for when n equals 1, we plug in 1 and we get -1 to the 1, or just -1 over 1. We plug in 2 and we get a +1, so -1 squared is a +1 over 2. And then we get a -1/3, +1/4. And now we can really see the pattern, etc. Okay, so graphing this sequence, we might see that, well, first off, this is going to be alternating from a negative number to a positive number. But the other thing I want to notice is that as we move along, these values are getting closer and closer to 0. So we might say that the limits as n goes to infinity of Sn ends up being 0. So in this case, we're going to say that the sequence converges to 0. Right? And we're actually going to define it this way. So a few last definitions. We're going to say that for a sequence Sn, if the limit as n approaches infinity ends up being some finite number. Up here was 0. If it's any finite number, then we're going to say that the sequence converges. We often say that it converges to that finite number. A couple other definitions that are going to come up occasionally is that a sequence is monotone if it only increases or decreases. So for example, both example 1 and example 2 are monotone. Example 3 is as well. Example 4 is not monotone because it increases and decreases, decreases, etc. Lastly, one last definition is that a sequence is bounded if there's an upper limit and a lower limit. Our first example is not bounded. There's no upper limit to what these values can take. Same with example 2 and example 3. Example 4, however, is bounded. There is an upper limit, so any number up here can serve as an upper limit. Any number down here can serve as a lower limit, and all of the values have to lie within this range. Therefore, in example 4, we would say that it's bounded. Cool. One last thing to think about is the statement that if a sequence is monotone and bounded, then, or let's say, then that means that the sequence converges. Okay, so I want you to think about that last statement a little bit, and we'll sign off there. Okay.